Hey guys, Mr. Palmer back with number 3 on the midterm exam review in physics. This one's involving a flea jumping up into the air. This is one of our problems involving acceleration from gravity. So this is going to be still an if-that problem like the last one. VI, VF, DAT. And let's look at the problem. In this case, you might look at it and say, okay, we're only given one piece of information. A flea can jump to a height of 0.64 meters, and we're looking for its initial speed when it leaves the ground, and we want to know for how long it's in the air. So if we're only given one piece of information, this height, well, it might seem like you wouldn't be able to do it. So let's go into our table and say, all right, our D is going to be 0.640 meters. And I'll just draw our little flea's jump into the air. The thing about these kinds of problems, a toss-up problem, which is what we would call this one, is that we know something a lot more about it, right? If it's jumping to some maximum height, it's reaching this point up here. And we know the point of maximum height in this problem, to a height. At that point, your V final is going to be 0. Regardless of your V initial, whenever you reach the maximum height, your V final is going to be 0. And we also know, because this flea is going to be on Earth, that the acceleration is 9.8 meters per second squared down. All right, and sometimes we call that negative, sometimes we call that positive. In this case, if we're calling the height positive 0.640, we're going to call the acceleration negative 9.8 meters per second squared, because it's down and positive is up of 0.64. So in this case, it's looking for us to find the initial speed, the initial velocity, and the length of time it's in the air. So we're going to put in our final velocity as 0, and as soon as you know 3, you know me. We can find the rest. So we're looking for this position at the top at maximum height. We need an equation to solve here. We want to know the initial speed, so that's our VI. And an equation that we can use is our VF squared equation. VF squared equals VI squared plus 2AD. So we're going to substitute in 0 for our final equals VI squared plus 2 times 9.8 times our height, which is 0.64. And I forgot to make this a negative 9.8. That's important, because when we bring this to the other side, I'm going to get negative VI squared on the left when I subtract VI squared from both sides. And I'm going to have what's left when I multiply these together, which is going to be negative 12.54. And we can just get rid of those negatives, right? We're not going to square root a negative number. Square root both sides to solve. And that leaves with an initial velocity of 3.54 seconds. It's jumping up. That's positive. So there's the answer to our first part, our initial velocity. For B, how long is it in the air? Now, this is a bit of a tough question. A lot of students get stuck on this because they'll do a problem and they'll say, okay, well, I've already found the initial velocity. I know that the final velocity is 0, so I can simply use equation number 1 to say 0 equals 3.54 plus negative 9.8 times the time. That gives us negative 3.54 when I bring it to the left side of the equation, divided by negative 9.8, or a time of 0.36 seconds. But that's not the correct answer, because that's not how long it was in the air. The length of time it was in the air was to the top and back down. We're only doing half of the trip. But the great thing is, we know that these trips are symmetrical. So in my little diagram, the trip to the top equals the time for the trip to the bottom. The distance to the top is equal to the distance to the bottom if we're on level ground. So we can simply double this, multiply by 2, and that's going to give us 0.72 seconds, which is the correct answer. Alternatively, you could say that, well, when I launch something up, I know that the V initial and the V final for something that's on level ground are going to be equal and opposite. That's another thing we remember about these. And we could use this same equation, equation number 1, in our kinematic equations, and use that final velocity. We could say when it hits the ground, we know it's going to be going negative 3.54 meters per second. When it launched, it was positive 3.54 meters per second plus negative 9.8 times the time. And if you do that, the solution, it gives you 7.08 when we subtract the 3.54 from both sides, equals negative 9.8 times the time. And when you divide, you're going to get the positive 0.72 seconds, the same answer. This is using the initial and final velocity start to beginning, and the first part was just doubling the time for half of the trip. All right, that's number 3, and I'll see you again at number 4.